Welcome to NCSA Learn. Right now, there is a massive rush to deploy artificial intelligence across every industry. But moving at breakneck speed to wire generative models into corporate networks is creating dangerous conditions. This timeline illustrates a significant risk for the immediate future. Gartner predicts that companies will abandon 60% of all enterprise AI projects by 2026, a massive waste of resources caused by poor planning. These failures happen when powerful models are plugged into unfortified environments. Without a solid foundation, AI systems invent facts, leak highly sensitive data, and rapidly drain computing budgets through inefficiency. As MIT Technology Review reports, AI is incapable of solving its own underlying infrastructural problems. It cannot fix the poor data quality or the fragmented systems it relies on for information. To solve these specific points of failure, hallucinations, leaks, and rising costs, enterprises require a multifaceted approach. We can break this down into a four-pillar architecture that addresses data, context, governance, and human oversight. Production-ready deployment depends on this structurally sound environment. Security and reliability come from the framework that houses the model, rather than the raw intelligence of the model itself. The first pillar is data at scale. An AI model is only as reliable as the information it accesses. When enterprises rely on fragmented legacy systems and inconsistent datasets, the AI struggles to find the truth and starts hallucinating. Success begins with a unified data foundation, where every piece of internal information is accurate, governed, and available for real-time retrieval. But even with perfect data, we face the second pillar, context engineering. Feeding an AI model too much information all at once dilutes the relevant details and spikes your API computing costs through excessive token use. Context engineering treats this as a precision filtering problem. It is the process of curating the exact minimum amount of data required for a model to answer a specific query accurately. This diagram shows how we achieve that targeted context using Retrieval Augmented Generation, or RAG. You can see an AI query passing through the RAG filter, which extracts just 3 specific facts from the database pool before sending them to the model. By passing only that tiny data package, we lower the compute cost meter you see dropping here and physically block the system from accessing irrelevant or conflicting files. Combining clean data with engineered context forces the AI to rely strictly on provided evidence. This targeted approach removes the model's need to guess, effectively eliminating the risk of assumed answers. The third pillar is governance and observability. Deploying AI inherently expands an organization's attack surface, creating new vulnerabilities that existing security protocols may not be equipped to handle. These models introduce specific new risks: prompt-based data leakage, adversarial inputs designed to trick the system, and uncontrolled resource consumption that can overwhelm your operational budget. Treating governance as a secondary layer applied after deployment is a significant security flaw. Control must be part of the initial design. This means embedding strict access controls and project boundaries directly into the architecture and workflows from the very beginning of the project. This real-time dashboard demonstrates LLM observability. It allows us to monitor the AI in practice, mapping its decision pathways, tracking token consumption, and isolating flagged security anomalies before they can affect operations. Absolute control over an AI's boundaries and behavior is the only way to ensure that operational autonomy remains safe for the organization. The final pillar is humans in the loop. There is an irony in AI automation. As these systems become more autonomous, the need for specialized human expertise actually increases. Running these systems requires people who can govern digital workflows, evaluate the model's outputs for accuracy, and redesign business processes as the technology changes. While software and model capabilities evolve rapidly, human critical thinking and institutional knowledge remain the most durable components of the system. Humans serve as the essential anchors. We keep autonomous tools aligned with the organization's mission and ensure they adhere to rigid security standards. When data, context, governance, and human expertise are united, the AI architecture stabilizes. These 4 elements work together to turn an unpredictable system into a secure engine for organizational velocity. Future growth belongs to organizations that prioritize these underlying systems of reliability over the simple acquisition of new software. Implementing this four-part framework provides the technical foundation needed to secure a resilient digital future, regardless of how the underlying technology evolves. Thanks for joining us on this episode of NCSA Learn. Stay safe, stay secure, and we'll see you next time.